Hey guys, this is Mr. Sal. We're going to look at some minimum and maximum problems, just some basic word problems involving quadratics. So thanks for watching. Don't forget to like, comment, and subscribe. So just in general applications, this is non-maximum, non-minimum stuff. All right. If they give us the y value, then that means they gave us x values. We just plug those into the quadratic and solve for whatever y is. Now, we'll see some that are functions on this. So you may see something like h of t, which would represent height as a function of time, for example. All right. Those ones aren't too bad, but it's when we have to solve for the x values, which is independent variable. That kind of makes things a little bit more interesting. Well, interesting, I'm using that loosely. But you may choose to factor if you can. In fact, you try to factor, and if you can't, then use the quadratic formula. All right, to solve some of these applications. An object is thrown upward at a speed of 176 feet per second by a machine from a height of 15 feet off the ground. The height h of the object after t seconds can be found using this equation. Round answers to the nearest hundredth, so we're looking at 2 decimal places on that. So the first question is, when will the height be 56 feet? All right, so on this one, it gives us the height at 56 feet. And we've only got 2 variables, which is nice. We've got t, which it says is time in seconds, and h is the height. So we know that we're replacing h of t, in this case, with the 56 feet. Now that we have that, though, we don't really want this to equal anything but 0, whereas right now it equals the 56. So let's get rid of that stinking 56. We'll subtract 56 from both sides. All right, if we wanted to, just because we like factoring so much, we could say, well, I'm going to take this negative 16 and multiply it by negative 41. And when I do that, I get the 656 business. Then I could try to find 2 factors of 656 that add up to 176. But I didn't get any that are going to come out really nice for us. So factoring portion of this won't do very well for us. All right. What that means is that we have to use the quadratic formula. So we're looking at negative b plus or minus the square root of b squared minus 4ac all over 2a, right? And, well, let's go and put that in then. All right, so this is just replacing these into the quadratic formula, and then from here we can solve. Now, the plus minus thing is going to give us 2 values. When we get those 2 values, we just need to kind of make sure that it works in context of this problem. Well, let's evaluate the inside of that square root. So 176 squared minus 4 times negative 16 times negative 41. All right, so we do have this in 2 parts, right? We got the plus or minus stuff. Let's do it one at a time just to see how that comes out, all right? Well, it looks like we will have 2 answers. Let's evaluate this first one here. It's negative 176 plus 168.38 all over negative 32. Now I got a decimal, but I am going to round this to the nearest hundredth, which is what it told us to do. So I got 0.238, so I'm going to round that to 0.24. Now this is t, right? Both of these are giving us a t value, which means we need to label this in seconds. So there's one of our answers. Let's go ahead and solve this other one, though. Negative 176 minus 168.38 all over negative 32. All right, so there's our second answer. And both of them actually do make sense, okay? Now, if one of these were in the negatives, which sometimes will happen, then we would understand, right? We're not looking at going back in time after whatever this machine is doing, throwing an object, okay? And we can also kind of understand that it would have 2 values because we're looking at it starting from a height of 15 feet, which is shown in the equation. And since it should be shooting it upwards, right? It should reach 56, we would say right here, but also maybe over in this area as well, okay? Right, because I don't know what kind of machine it is. That makes sense that it would cross over the 56th height level twice. Well, at least according to this quadratic. I mean, could you check this? Yeah, you could, right? I mean, you just plug these two time values into the function and make sure that it comes out, well, we rounded, so we should be close to 56, okay? All right, when will this object hit the ground? So again, we're looking at height on this. And the height at the ground, we should assume, is 0, all right? So we'll just replace h of t with 0. All right, so this is new. And we could try to multiply a and c in this, negative 16 and 15, just to see if we could factor that out. It's going to be a huge number, and I don't really want to do the work on that. Not that I'm great at typing this in my calculator. But it can't be factored. We can't find two factors of whatever that product is to get 176 anyways. So we're going to go back to the quadratic formula. And let's just replace our a, b, and c values in there. All right. Well, let's go ahead and evaluate this then. I'll just do the discriminant first. Okay, so the square root of 176 squared minus 4 times negative 16 times 15. All right, let's find out what that is, the actual square root of that. All right, so this is what we have so far. Let's, again, separate this into two different expressions so that we can solve both of them. Because, yeah, this is what t actually is, right? All right, and again, I'll start with the plus stuff on this one. So we'll add that 178.71. Just from this first part, right, we got that negative 0.08 rounded. And that's in seconds, but again, we don't want a negative value for the seconds. So that's not going to work for us right there. So let's look at the other one. We did plus on that one, so we'll do subtraction on this one. And what does that equal? So 11.08. And again, that's in seconds, which we can have positive value in the seconds. So that should work. Now again, if I went back and I plugged this into my original quadratic there in the beginning, I should get 0, or about 0 because we rounded, right? A large explosion causes wood and metal debris to rise vertically into the air with an initial velocity of 160 feet per second. And with this function, it gives the height of the falling debris above the ground in feet, t seconds after the explosion. We want to use the given function to find the height of the debris 2 seconds after the explosion. 2 seconds is in time, right? So this one isn't, I don't know, I didn't think it was too bad. If we were to write it out, we want the height as a function of time with 2 seconds. So we're just going to replace all the t's with 2's and see what we get, right? So I got 160 times 2 minus 16 times 2 squared. So this is the height after 2 seconds, 256. And it says up here, that's in feet. So after 2 seconds, the debris would be 256 feet in the air. All right, how many seconds after the explosion will the debris hit the ground? So this is the height where at the ground, which, as we've seen already, is 0. You could use the quadratic formula on this one, but I'm going to use factoring. You can choose to do it if you want. Just the c value on this would be 0, right? If we were to rearrange this, we'd have 0 equals negative 16 t squared plus 160t. And then if you need to see that c value, it's plus 0. Because it's the additive identity, right? Well, I'm not going to do that. I'm going to take this, and I'm going to factor out whatever I can from these two terms. So I can see that I can factor out a 16 from both, but also a t. And what's left over? I'd have a 10 minus t. That's not too bad. And we remember just from the purple stuff that we know this equals 0, right? So I have two values. I have this 16t If I can get that to equal 0, then that would be true, which means t is just 0, because divide both sides by 16 and we're good. But that was right as the explosion happened. We don't really want that value in there, all right? What we do want is the time after the explosion. So let's see if this t, 10 minus t, gives us something a little bit better to work with. And if it equals 0, then we're in good shape. It'll still give us a true statement. So this would be 10 equals t. I added t to both sides on that. Well, that's 10 seconds, which sounds like a good value for us, all right? So on that one, we got 10 seconds. So let's just check on this. We'll use the height with the time that's 10 seconds. So I'm just replacing all the t's with 10. And this one, there was no rounding involved, so it should come out pretty clean. 160 times 10 minus 16, and we'll multiply that by the 10 squared. All right, so these two, 1600, and then 10 squared is 100. And 16 times 100 is 1600. 1600 minus 1600 is 0. So, now I showed a lot of work on that, which isn't necessary because the calculator will do that for you to evaluate that expression. All right, vertexes, or is it verti? I don't know. In any case, vertices, that's right.
Is this at 7.7?
Maximum and minimums really is just the vertex, right? So if we remember, if we look back on a graph, as long as that a value is positive, we'd have something that looks like this, okay? And the maximum value is the actual tip of that parabola, which is the vertex. But it wouldn't matter if the a was negative, right? Then we'd end up with something like this. The vertex then becomes a minimum, though, because it's the lowest value in that dip. And of course, you know, you got your axis of symmetry, but when it asks for some kind of maximum or minimum value, then we kind of look for the vertex for the most part. Now, on that last problem, we could say, at least piecewise, right, because it hits the ground and then it would just kind of stay there. We wouldn't expect to see any negatives, so some context is important. I really like using the vertex formula because there's no need to complete the square stuff. And then once you get that x value or h, then you just plug that into the quadratic and then figure out what your k value is for the corresponding y value. A patient has an illness that typically lasts about 24 hours. The temperature T in degrees Fahrenheit of the patient T hours after the illness begins is that stuff. Round all answers to one decimal place. When does the patient's temperature reach its maximum value? All right, let's check this out. And yeah, I'm going to use that vertex formula stuff, right? And this is going to give us the x value in the vertex. All right. Well, the b value is at 0.374 and the a is negative 0.017. Then at this point, we're just evaluating it to find the x value of the vertex. Positive 11. Now the x in this case, I apologize, I probably should have written the t on that. T is the time. Wait, no, that's a small t, which is, that's t hours. So that's 11 hours. 11 hours after the illness begins, apparently. Okay. Now, this may be helpful, but for the most part, the body temperature starts at 98.7. So if there was no illness here, right, then that's the temperature that you would start out at, which is why it's plus that 98.7, which we know is also the y-intercept. All right, what's the maximum temperature? Well, the maximum temperature should happen at the hour that we have for the maximum temperature, which is what we just solved for. So that's where we get that f of negative b over 2a stuff, right? So the actual temperature would happen after the 11 hours. All right, so we're just replacing all the lowercase t's, time, with that 11 hours stuff. And, well, we should be able to evaluate this right away, right? All right, when I do this, when I put this in my calculator, I got 100.757. I didn't even round that. But it does want us to round to one decimal place, so that's what we'll do. So we'll just say that that would be 100.8 degrees Fahrenheit. NASA launches a rocket at t equals 0 seconds. Its height in meters above sea level as a function of time is given by this function. Assuming that the rocket will splash down into the ocean, at what time does splashdown occur? All right, splashdown, splash, we just went from the ground into the water, right? So I assume it's going to splash down when it hits the water, which has a height of 0. So we're going to replace the height of this thing, right, h of t with 0. Now you could multiply negative 4.9 by 416 and get, well, you'd still have a decimal, and finding factors of that that add up to 154 is going to be a pain. So we're going to go right into the quadratic formula. And we'll just plug in the a, b, and c values into the quadratic here. All right, so there's our setup, and I'll just evaluate the discriminant first, or the inside of the square root there. All right, let's find that square root then. All right, and yeah, that is rounded. So we got plus or minus. We're going to have two values on this, but we should only have one that makes sense. So, I mean, I assume one of these would be some kind of negative value. So let's write this twice here. All right, we'll do the minus one first. So negative 154 minus 176.8 all over negative 9.8. All right. Oh, and the other one as well. All right, now let's see what this gives us. The demand equation for a certain product is given by P is that stuff where P is the unit price of the product, and X is the number of units produced. The total revenue obtained by producing and selling X units is given by R, the revenue, is X times the unit price P. Determine prices P that would yield a revenue of $7,910. So that's our revenue that they just gave us. And if we look at that, 7,910, I'm just replacing that for R in this equation that it gave to us before. And that's going to be X times P. But we also see that P is 130 minus 0.065X. So let's replace the P as well. And what this does, replacing the P, the unit price, is it gives us a new equation, but with only one variable, which is kind of what we want. I mean, not for the same purposes as we have in 980, but this is nonlinear, so we're looking for a quadratic out of all this. All right, so the 7910 was the revenue, which is equal to X times P, which really just came from this equation that they gave us. All right, well, let's simplify this. I'll distribute my X into this. Now, since we're solving for X, we really don't want it to equal anything, right, because we have a quadratic. So I am going to subtract 7910 from both sides. Not only that, but I'm going to rearrange this. Instead of it being 130x minus 0.065x squared, I just want to see it in standard form, all right? So I got negative 0.065x squared and a positive 130x. Now over here, I'm going to subtract 7910 from both sides. So it ends up being minus 7910. But now this equals 0, which is what we want, because now we can use the quadratic formula, which is what we'll do now. let's go ahead and go in then and replace all of our b's, well, a, b's, and c's with the values from our quadratic. All right, let's go ahead and evaluate at least just the inside of the discriminant there. All right, let's take the square root of that stuff. All right, let's go ahead and split this one up then. All right, let's just evaluate these and see what we get. And then let's do the addition as well. All right. And that gives us the x value, which is not what we actually wanted. Okay. So, I mean, we can go back and read the problem. X just tells us the number of units produced. What we really want to know is the prices that will produce these, right? Now, the price is also the unit price, P, is based off of however many units are produced. So we're going to go back to the P up here at the top. And we've got to plug these values in to that equation for the x, because that's what we solved for here. Those are the x values. And then we got to evaluate those to see what the actual prices would be that would yield that revenue. And we'll start out with the 1937.15. All right, and when we evaluate this, so that's our P value, and that's a price, so it should have some kind of money attached to it. I suppose it didn't. No, it did say in dollars, so that'll do. But let's check the 62.85 as well. All right, and we'll plug this into a calculator just to see what it gives us. All right, so we have these two prices. That's the unit price for whatever they are selling here. And they kind of have to decide based on this formula if they're going to sell this thing for $4.09 or $125.91, right? In order to reach that revenue, you know, you could be the judge on which one you would sell it for, but we don't really know what we're selling here either, so there you go. All right, this is the moment most of you, every one of you, have been waiting for. The return of systems of equations in 3 variables. Well, we may see some in 2 variables, but you wanted the 3, so here it is. Just if they want us to write the equation for these, it's nice to use a system with this standard form for this quadratic stuff. Now, we just need to solve for the A, B, and C, so we should end up with 3 of them based on the 3 points that they give us. They could give us more, but we only need 3, otherwise we end up with more equations than we need. The nice thing about this is when they do give us a point, such as, I don't know, 10 and negative 15, like this, all right? So to find the A, B's, and C's, you've got to replace the X's with the X value that was given, like in this case it would be 10. And then the Y value with the negative 15. It's just uncommon for us to use the quadratics this way. It wouldn't be Y equals that stuff. It would be that stuff, and then it would equal the Y value. That sets up our equation so that we can plug them directly in, or make, well, yeah, that puts it in a format that we're used to seeing anyways. This one didn't give us any points directly. They didn't say, here are the points. But we do have points to use. For example, sorry, I kind of looked at the y-intercept first. So I'm going to look at 0, negative 6. But we could, and we will end up using 6, 0 as well anyways. And we got to be careful with this one right here, with how it's like right in the middle.
What about a 4, 6?
Let's do it. We'll use this 4, 6 point because it's very clear that it's going through there. And not so clear that it necessarily goes through 1, 0, even though it does. Let's say we didn't want to take that risk, because as you guys know, math people do that sometimes, right? So we've got to be careful with how we assume things sometimes. Now, it would be helpful if we could remember with that standard form stuff. The C value actually is the y-intercept, which we have identified as being 0, negative 6. So automatically, I mean, we see the C value in this is going to be -6, whatever it is, okay, for the formula. Not only that, but it's going to work for all of the rest of the equations that we make, which means in reality this one, well, you guys wanted system in 3 equations, should only give us 2. All right, here's what I mean by that, okay, is we got this, we're going to use the same form right here, this standard form stuff. So let's look at this. Now we don't know what A and B are yet, but we can start with this point. Let's start with our 4, 6 point, okay? Now 4 is our x value, so I'm going to replace the x's with the 4 from that point. Just like that, okay? Now 4 squared is 16, so I end up with 16a. That should look a little better. And then instead of b4, I'm going to have 4b. Then we got the -6. And this equals the y value, which we have at 6. Well, if I wanted a real system of equations, I want all my variables on one side and all my constants on the other side. So I don't want that -6 there. And I'm going to have to add 6 to both sides. Well, that gives us an equation now to work with in our system once we finish it. So we've got to figure out what the second equation is, right? And the next point I'm going to use is the 6, 0 point, which we also had, right? Because we're not assuming 1, 0 is there. I mean, could you use 0, -6? Yes, but it would just tell you the C value on that anyways. It's going to eliminate those 2 first terms, ax squared and plus bx, because the x value is 0. So we've got 6, 0 on this. Let's go back to the standard form there. But on this one, the x value is 6, so let's go ahead and replace that in there. And the y value is 0. All right, so 6 squared is 36, and then we'll multiply that by a. And again, I don't want that to be b6, even though they kind of look the same. And I don't want that -6 there, so I'm going to add 6 to both sides, which gives me this equals 6. So I've got the 2 equations there. Let's write those separately now. There is a nice system, because it's only got 2 equations, right? Well, we got to choose now which of these 2 variables we want to eliminate, A or B. All right, if I'm going to eliminate b, then I'm going to have to multiply this equation. I would multiply it by 3, just so I can get a lower number out of that. And then I would multiply the second equation then by 2. So that would give us, I apologize, I should have made one of those negatives so they'll be opposite. Very good. And that way the b's will cancel. And now we're ready to actually eliminate those b's because they're going to zero out right there. And I've got 48a minus 72a. All right, yeah, sorry, 3 times 12 is 36. 36 minus 12 is 24. So we'll divide both sides by -24. And our a value is -1, which I can go into what we have up there. I don't want. And I will replace the a with -1. Now, I assume if you put that on the homework as just -x squared, you'd be fine. Now that we have the a, though, we can solve for the b value as well. You guys want to use the green or the purple equation for that? The purple one's closer for me. So I'm going to replace the a value with -1 there. And 36 times -1 is -36. All right, now that we know b is 7, we'll go into the equation, the standard form, and replace b with 7. Well, that's it. I mean, if you want it to be y equals, that's fine as well, but there at the top, that's our answer. That's better. We want to find the equation for this, these 3 points, the quadratic that goes through these 3 points. If it was linear, that'd be, you guys miss those linear ones now, right? But it's going to work exactly the same way. Let's look at our standard form on this. All right, and we know the x value. I'm going to start with 111 on this one. So my x's I'm going to replace with the 1 that it gave us. And the y value is 11. So just to, simplify this, we got 1 squared, which is 1, so I really just got a plus 1b, or just b, plus c equals 11. There's my first equation, which I do want to keep track of this, okay, because I should end up with 3 equations, which will then allow me to solve for b and c, a, b, and c. Next up, we'll do 214. And so I'm going to replace my x's with 2 and y with 14. All right, 2 squared is 4, so we've got that 4a, plus we'll just make that 2b plus c equals 14. And that's our second equation that we want to keep track of. That's an arrow, not a negative. Well, let's look at that standard form once again, right? ax squared plus bx plus c. And let's go and replace the values that we have in that one, the x and y values. All right, negative 1 squared is 1, so we still have that a, but that becomes a negative b plus the c equals 20. So there's our third equation and all of that. Let's write these separately now. So now that we have that, this is our system with 3 variables. And you can choose if you want to use matrices, which I assumed you didn't. So let's use elimination to solve this, okay? I'm going to choose first to eliminate the b's, just because I got that negative b, which is going to make that pretty convenient, all right? All right, since I'm using the orange and purple one, I can just add those directly because the coefficients of b's are already opposites. And I've got 2a plus 2c equals 31. But I've got to eliminate the b's from that red equation as well. And that purple equation, I'm going to multiply all the terms by 2. Yeah, that will eliminate the b. So I'd have 2a minus 2b now, plus 2c's, and that would equal 40. And again, we can add these directly now, right, because I multiplied this 1 by 2 to get this second equation. And that it will eliminate the b's on this one. So I've got 6a plus 3c equals 54. And this gives us now a system of equations in 2 variables where we can solve for either a or c. All right, now that we have this new system, we should be able to eliminate either the a or the c and solve for the other one. So which one do you guys want to eliminate? To eliminate a, I'm going to multiply this top equation by negative 3. So that's going to give me negative 6a minus 6c equals negative 93. All right, and this is what I have now. And when I add these together, it will eliminate the a's. So I've got negative 3c equals negative, negative 39. So we're going to divide then both sides by that negative 3. And that would give us c equals 13. So in the standard form, y equals ax squared plus bx plus c. We already have the c as positive 13, so we're going to fill that in. We just got to figure out what the a and b values are as well. So now that we know that the c value is 13, we can use one of those 2 green equations with the a's and c's to solve for a. All right, so 6a plus 3c, and that's 3 times 13 now, should equal 54, and we'll solve for a then. All right, then we'll divide both sides by the 6. All right, if I remember seeing right on the homework, they don't want those fractions as pretty as they are. I'm okay if you use the fractions if it's necessary on the exam. But since this is for the homework, right, this would be 2.5. So we have an a value and a c value. We just need to figure out what the b value is. And we can go back to that orange, red, or purple equation. We just got to figure out which one we want to use to solve for B. And I already know what my A and C values are. Well, we'll combine the 2.5 and 13. All right, so negative 4.5, we'll just take that plus out of that, make that minus 4.5 right there. There it is. One leg of a right triangle is 13 centimeters. Let h be the length of the hypotenuse and p be the perimeter of the triangle. But we want to express this as h, this function, h as a function of p, which means we want it to be h equals something. All right. So it may help us to see this in a picture. It may not, but we're going to do one anyways. So, right, if we had any right triangle, we don't really care what it looks like. We know one of the sides is 13 centimeters. And the hypotenuse, we'll just say is h because they said let h be the hypotenuse. But we have that other leg which we don't know what its value is. But if we asked you to solve for its value, you could do it. You take the square root of h squared, and then we'd subtract the 13 squared. Now just to demonstrate that, right, the Pythagorean theorem would have given us 13 squared plus that missing leg squared, we'll say it's a, and then this would have equaled the hypotenuse squared. Now since we're solving for that leg, we would subtract 13 squared from both sides. But we don't want a squared, we want just a, so we would square root both sides, which is how we got that leg. Why do we need that leg? Because we're looking at perimeter, which means we're going to have to add all of these values together, 13h and the square root of h squared minus 13 squared. All right, well, if we were to find the perimeter of this thing, just like we said, right, the perimeter would be the 13, and then we would add the square root of the hypotenuse squared minus 13 squared, which is 169. We'll get to that. And then we would add the hypotenuse. Now our objective here is to write this in terms of h. So we want it to be h equals something. But this is a good formula to start out with. The problem is we got that square root of some kind of binomial, which is kind of stinky. But we can deal with it, right? Now to deal with it, we got to get rid of that square root because we have an h inside of it, which we don't want. So we got to get rid of that square root somehow, just the same way we've been used to doing it. Again, this is just a little bit more abstract. So I need to move the 13 and the h to the other side of the equation, all right? So to do that, I'm going to subtract 13 from both sides, right? But I also need to subtract h from both sides, so minus h. That looks a little jacked up because I didn't give myself enough space, but there's no terms that I can combine there on the left. So I've really got p minus 13 minus h, and then this would equal now the square root of that h squared minus 13 squared. I'll just put 169 in there. Well, we got that square root, but we don't want it, so we're going to have to square both sides. Now to do that, we're going to have to square that p minus 13 minus h. That doesn't mean we're squaring the terms inside directly, right? It's really p minus 13 minus h times p minus 13 minus h, which I'm going to write out. All right, let's go ahead and multiply these out. And so I've got that p times the parentheses. Then I've got negative 13 times the parentheses. And the negative h's. And this equals h squared minus 169. Well, let's go and distribute then the p, the negative 13, and also the negative h. That's kind of big. Well, some of these, if I remember right, will cancel out maybe. Oh, none of them do. That's even better. Okay. We just have to keep in mind what our objective here is, right? We want this to be h equals something. Okay. Well, let's see what we can combine at least first. I got that p squared, which I can't really combine anything with. So I'm going to have that p squared still. There's that one. What about the negative 13p? There's another one. And I don't see any other just constants with the p, so that's going to be negative 26p, which is important to have. Next up is this negative hp, and I got another hp over here, so that's a negative 2 hp. And I got this 169, there's nothing else to combine that with. And this 13h with this one would give us 26h, and also the h squared. I don't know, slightly simplified anyways. Well, what we need to do now is we need to get the h's all on one side of the equation here, and then all of the everything else that doesn't have an h on the other side. And then we'll manipulate it so that we can get an h out of that, so that it's just h equals, which is what our objective here is, right? So to start out, I'm going to put my h's on the left. So I don't want that p squared there, so I'm going to subtract p squared from both sides. And also, yeah, we got that negative 26p. I don't want that there because it doesn't have an h, right? So I'll have to add 26p to both sides as well. The negative 2hp does have an h with it, which is good. We want that. But the 169 doesn't, so I'm going to subtract 169 from both sides. And the 26h has an h in it, which is good. We want that. And the h squared also, we want to keep that. All right. So, oh, but I got that black h squared, which I don't want on the right side, because I want all my h's on the left. So I am going to subtract h squared from both sides, and we see that gets rid of the h squared on the left side as well. So what do we end up with? Negative 2hp plus 26h equals, right, those canceled out. I got the negative 169 minus 169. So this is what we have now. On the left side, I've got negative 2hp plus 26h. Here's a nice thing about what's right there is there's only one h for both terms. So hopefully you're thinking factoring, because I can pull one h out of both terms, right? So that would leave me with h times negative 2p. 2p plus, now it's 26, equals that stuff in red. I will write that in descending order. Okay, that's better. Well, I want the h by itself, so what am I going to do? Divide both sides by negative 2p plus 26. But that's for the whole side right there. Negative 2p plus 26. And we can see right there that those are going to cancel, which would leave us with just the h. Done.
Oh, sorry.
Just by, I don't know, default, because we're so used to it. Some of you may look to factor out the red term there in the numerator, or even the bottom term there. And, I don't know, on the homework it looks like they have it that way. I don't really care. For example, they factored out a negative 2 and then changed all the signs above it. Alright, but I like it like this. No need to go any further.
You don't want us to combine all that stuff?
That is as far as I'm going to take this thing. This graph is shown. That was nice of them. Use the graph to solve. Negative x squared plus 10 equals 1. So notice they just took the y value here and replaced it with negative 1. So we're just looking at y values of, I said negative 1, didn't I? 1. So I find on my graph where y is 1 right here. And if I made it a line, then I would have this line right here, something like that. And I can see that it intersects that line right here and here. So those two x values are negative 3 and positive 3. That is all. Find the domain of this function. It's really just asking what x can't be, because it's just a denominator problem, right? So, remember with these, we don't really care what the numerator is, so we don't care now either. And we're just going to take that x squared plus 7x minus 60 and find two factors of negative 60 that add up to positive 7. I'm going to use 12 and 5, negative 5. Well, that gave us both of the values right there. Right, if we were to factor this out, we'd have x minus something and x minus the other thing. And it'd be x minus 12 and x minus negative 5, which really becomes plus 5 right there. Now, these cannot equal 0, because we can't have the denominator ever being 0, which means that if I made x minus 12 equal 0, or not equal 0, then it would be fine, which means x cannot equal positive 12. But over here, if I could get x plus 5 to not equal 0, that would be nice. So x couldn't possibly be negative 5 either. These are excluded values, which is all we really need to write in this domain stuff. So the domain is, we need some fancy brackets. All right, so the domain is x such that x cannot be 12, but also that x cannot be negative 5. Fancy brackets. They have an and in between that, but either's good.
Also, you can